So we did exponents because radicals are related to exponents. You must have seen this pretty much, for a long part of your life. So what do we call that? Square root of x. Now, what does square root of x mean? Well, you just take the calculator, you put the square root of x, and that's what you guys did. You probably did. But in terms of an exponent, this is equal to x raised 1 over 2. And typically, if it is a square root, we don't specify the way I'm about to do now. But any other root, we've got to specify the type of root we have. So if I put a 3 there, that simply means x raised 1 over 3. What should that equal to? X raised to the power of 1 over 11. And you can see that it's just habit for me that anytime I have an exponent, I put parentheses right away. That is good practice. You see exponents, you always put the terms within parentheses so that you don't make mistakes. In general, if you see something like that, you have the root, you have x, and then there is that n. That simply means the nth root, and that would equal to x raised 1 over n. So that would be the second root, third root, 11th root, and nth root. So even roots of negative numbers do not result in real values. In other words, you're not going to get real numbers as the answer. So what do we mean? I can't do the square root of -1. I can't do square root of -21. I can't do the 4th root of -21. I can't do the 6th root of -27. They're not possible because they're all even roots. Yes? Now, odd roots of negative numbers is possible. In the sense, you can take the odd root of -1. Third root of -1 is -1. Fifth root of -1 is -1. The 15th root of -1 is -1. Good. So an easier way to verify this is pick up your calculator, put in, square root of -21, it'll give you an error. But if you did cube root of -21, you wouldn't have a problem. talking about a calculator, in the calculator, you will see the root button, you would see the third root button, but the enter is probably missing. So you can do the enter in the calculator for some number, let's say 72. There is a symbol, the power symbol, and you can put whatever value you want. So if you want to find the third root, I'll simply do 72. The caret button to the calculator followed by 1/3. So square root is available in the calculator. Cube root available in the calculator. Any other power, you have to evaluate it this way. So 16 raised 1/5. That is a standard notation. Domain of radical expressions. What is the domain? From long time ago, we did domain. So what is the domain of a function? It is the set of all x values. So the domain is the set of all x values. And we have seen with rational expressions, we can't have the denominator to be 0, correct? So anytime you have a number, for instance, if you have a function 1/x plus 1, the domain here would be, let's see if you remember. Is it all real numbers? Except -1. So all real numbers except x is equal to -1. And you may say, well, how did you come up with that? Well, all we have to do is set the denominator equal to 0 and solve for the value of x. So x plus 1 equals 0, which would mean x is -1. And that expression is a rational expression. And that is from the previous chapter. Now we have a radical expression. Square root of x minus 2. Could I plug in any number I want inside in that function? I cannot. So what numbers are not possible? Could I plug in 0? If x is 0, I'll have 0 minus 2. That will become square root of -2, right? Is that a real value? No. We can't take the square root of a negative number. So 0 cannot be a value for x. So how do we find the proper domain? All we require is whatever term that is inside the root to be greater than or equal to 0. Just like how we set the denominator equal to 0 with a rational expression, here, we take the expression that is inside the root and set that greater than or equal to 0. In other words, we either want that expression to result in 0 or a positive number. So if I solve for this inequality, I'm going to add 2 on both sides. I will get x to be greater than or equal to 2. So the domain of that function would be all real numbers greater than or equal to 2. So the expression that is inside the root is x plus 4. And I want x plus 4 to be bigger than or equal to 0. In other words, I want that to be positive or equal to 0. If I subtract 4 on both sides, the solution is x greater than or equal to -4. So the domain here would be all real numbers greater than or equal to -4. So we want to set that expression, which is 1 minus 2x, to be greater than or equal to 0. So the first step would be to subtract by -1 on both sides. So -2x would be greater than or equal to -1. We want to solve for x, so what should we do? Divide by -1 or multiply by -1 on both sides. If I did that, I will have 2x greater than or equal to 1. Is that correct? No, why not, Jan? Okay, but I did something else. I multiplied or divided by -1, but I forgot to do something. What did I forget to do?
Is it supposed to be equal or greater than 0? Or...
No.
Okay.
What did I do? I forgot to flip the sign. I didn't forget, I just intentionally left it. So that you guys can realize. So anytime you multiply by a negative or divide by a negative in an inequality, you've got to flip the inequality. Now we've got to divide by 2 on both sides. So 2x over 2 would be less than or equal to 1 over 2. So x is less than or equal to 1 over 2. So the domain is all real numbers less than or equal to 1/2. Good. So in these problems, we're going to assume that everything or anything inside the root would be positive if we have an even root. But all we're trying to do is express the radical in terms of a rational exponent. So third root of x raised 4. So the very first step would be to have x raised 4. Third root would mean raising it to the power of 1/3. But then we know properties of exponents. 4 times 1 over 3, I will get 4 divided by 3. Yes? Suppose we have the fifth root of x squared. Whatever I have inside the root must go inside the parentheses. So x squared. What does the fifth root mean? It means 1/5. So the answer, you multiply 2 and 1/5, it's 2/5. So you get x raised 2/5. No, I simply wanted you to apply the root and write it in terms of the exponent. So that expression inside the root must go inside the parentheses. So AB raised 1/3. We can just leave it as is. The expression inside the root is 2x. That should go inside the parentheses. The root here is the sixth root. So you have to raise it to the power 1/6. You can leave it as is. I saw your mistake, you put it at 6. Over here, a minus b raised 5 is inside the fifth root. So that has to go inside the parentheses. Going to raise it to the fifth power. When I multiply the 5 and 1/5, the 5s will get cancelled. I will have a minus b raised 1. But what is a minus b raised 1? It's just a minus b. Over here, the term that is inside the root is 9x minus 1. It is the sixth root, so I'm going to raise it to the power 1/6. Good. A common mistake I use that as an example. 9x minus 1 raised 1/6. Raised 1/6. People would write this as 9x raised 1/6 minus 1 raised 1/6. That's absolutely incorrect. Life is not that easy. You cannot apply the root to sums. In general, the nth root of a plus or minus b is not equal to the nth root of a plus the nth root of b. Now, there are some numbers which will satisfy that, I pick a and b to be 0, right? Then they will be the same. But I'm just saying, in general, let's not practice that. A plus or minus here. So here, we're just going to do things in reverse when compared to what we just did earlier. Earlier, we converted a radical and wrote it in terms of an exponent. Now we have exponents and we want to write it in terms of a radical. The idea is pretty straightforward. So I just have to split the denominator exponent away from the actual exponent. In other words, I'm pulling that 1/3 out, writing it this way. They are the same, correct? If I multiply 2 and 1/3, I will get 2/3. But what do I know? Whatever that is inside the parentheses must now go inside the root. So I'm going to put a squared, but you can't forget the root. Should I put 3, 4, 5, 6? What should go there? 3. So this is the third root of a squared. The expression inside the parentheses is 4a. And that has to go inside the root. So 4a. What should go over here? 5. You see, the process is just the reverse of what we just did. That one is a bit tricky. What is the very first step?
The exponent.
Separate the exponent. How would we do that, Michael?
It would be in parentheses a plus b to the power of 7, and then you put another set of parentheses, and then it would be 1/9.
Very good. So that term that is inside the parentheses is the term that needs to go inside the root. So a plus b raised 7 is going to go in there. What should we put there? 9. So it is the 9th root of a plus b raised 7. So first step would be to split the exponent. So I'm going to write it as 4ab squared raised 1/5. If using multiple parentheses is confusing, you can always use the square bracket. So whatever that is inside the square bracket must go inside the root. But before I put it in there, that too can be applied to each of those terms, correct? So 4 squared is 16, a squared, b squared. Yes? What number, what root should I have? Over here,
5.
5. Good. Are we clear?
Yeah.
Now,
Would it be better to have it in parentheses or
come again?
would it be better to have it in the power of 2 or distributed?
It depends on the problem. In some cases, we want to just leave it as is. In some cases, we would, apply it. So it varies from problem to problem. So in this case, either you could have left it within parentheses, but it's better to apply the power. So here, have ab squared going to split the exponent. Yes, 3 times 1/2, 3/2. Whatever that is inside the square bracket is what's going to go inside the root. But I have a cube there, so a cubed and b, what is 2 times 3? 6. So both of them are acceptable. You can do it that way, or you can simply leave it this way. Yes, but in practice, which one do we prefer? We usually go for that. The square root of a cubed multiplied by b raised 6. Are we clear?